7-6. And 7-6 is all about transformations. All about transformations. So what we're doing is we're taking shapes and triangles, and we're dilating them. They're either getting smaller or they're getting bigger. Okay? If their scale factor is the same, then it is a similar transformation. Okay, a couple of things to talk about in this lesson. You know how like the letter M stands for slope, right? So these math people way back when, they decided that K would stand for the scale factor. So now, when we're talking about scale factor, we're going to say K equals, and we're going to put our scale factor. So that's our new shortcut. K stands for what? Scale factor. K stands for scale factor. Can y'all see? Is there a glare? Alright, so here's what happens. There's two kinds of dilations. It's either an enlargement or a reduction. Okay? This one right here, guys in the back. This one is an enlargement, which means it gets bigger. So you have what's called a pre-image and an image. Your pre-image is your original, your OG. So this is your pre-image, the first one. This is your pre-image. And then the one it's going to is called your image. So from your pre-image to your image, did it get bigger or smaller? It got bigger, so it's called an enlargement. Well, down here, from our pre-image, so this is our pre-image, to your image, it got smaller, which means it's a reduction. Bless you. So your scale factor determines whether it's an enlargement or if it's a reduction. If your scale factor is greater than 1, it's an enlargement.
Where's the image on first?
The image is right here. If your scale factor is greater than 1, your dilation is an enlargement. If it's between 0 and 1, it's a reduction. So if the scale factor is greater than 1, it's an enlargement. If K is smaller than 1, then it's a reduction. Dylan, wake up. Alright, let's practice. Ready? That's just the base. Like, here's what happens, okay? This is what you're going to do every time. Determine whether the dilation from A to B. So start with A and go to B. Is it getting bigger or is it getting smaller? Well, you can look at that and determine it, right? Okay, so that's the easy part. From A. So from A to B. Well, it obviously got smaller, so it's a reduction. That's it. There's only one more part, though. Then, find the scale factor. Here's how you find the scale factor. The scale factor is found by putting B divided by A. Here's what I mean by B divided by A. You count the number of boxes of B and the number of boxes of A, and you just simplify. So let's count this as a half and this as a half. So that's going to be a half, whole, and a half. So that's how many boxes? So 3 divided by, now let's go count A. 1, 2, 3, 4, 5, 6 boxes, right? So the scale factor reduces to 1/2. You have to put B over A. B over A. So there's 2 answers to all of these questions. Reduction or enlargement and scale factor. So your 2 answers would be K equals 1/2 and reduction. Yes, ma'am.
Couldn't you just figure it out from the problem? Because says A is 6 and B is 3.
It tells us the answer.
I know, this told you the answer. This is the answer. That's not always going to be there.
Okay.
I was just explaining it in my words. You're right. That is the answer.
Okay.
But that's their answer. That's not the problem. Does that make sense? Okay. So now here's the part, how do we find the boxes? Well, look right here. You can't count these boxes because they're not on a straight line, right?
Nope.
So you'd have to find boxes on A and B that are on straight lines. So I would count A and B. Well, first of all, from A to B, did it get bigger or smaller? Bigger. It got bigger, right? From A to B, it got bigger. So it's in enlargement.
It's always B divided by A.
But you always, to find the scale factor, you always do B divided by A. So count B first. How many boxes?
4.
And how many boxes in A?
3.
So can that reduce any further?
What?
I counted 1, 2, 3, 4. 4 boxes on B. And then you go over here and you count 3, 2, 1 boxes on A. So your scale factor is always B divided by A. So it's 4 divided by 3. So you have 2 questions. Enlargement or reduction? Enlargement, and the scale factor is 4/3. See, this is why I show you this. You see, they found the distance. You see how they're explaining it? I don't use all that. I just count the boxes, right? Okay, can you try 1A and 1B? If you're kind of confused on where the shapes are, does this help you see where the shapes are? This is triangle B. This is triangle A. Oops.
How can you fill in large and small?
Okay, so you see A from here. Well, how many boxes are on A? 1, 2, 3, 4, right? Well, how many boxes are on B? 2. So from A to B, there's more boxes, so they got bigger.
Thank you.
So look on this one. From A to B, you don't even have to count the boxes, right? Because there's a lot of boxes, but then there goes down to 2. So it got smaller.
You still have to do the math. So you have to count.
You have to, yeah, you're right. Say that again. So it doesn't matter which straight line, as long as it's a straight line. So are you on 1A or 1B? I would use this one over here. So for this scale factor, I would do 1, 2, 3, 4, 5 divided by 1, 2, 3, 4.
Yeah, but that's all it's B.
Huh?
You can't reduce it.
You can't. That's it.
Can we go ahead and go on to the next?
Okay, hold on, stay with me. So this is a enlargement, right? It's funny how y'all are anxious to do things that I haven't told you to do, yet you won't do things that I ask you to do.
That's kind of how life works.
From A to B. You'll always, in my class, you'll always go from A to B. Okay, so from A to B, did it get smaller or bigger?
Smaller.
It got smaller, so it was a reduction. So now you will have to reduce because you have B divided by A. Okay, Christian, how many B boxes were there?
2.
Now, question. Christian counted right here, right? So there were 2. How many boxes on this side of A were there? Okay, now, I know I can reduce, but how many boxes are there on the bottom of B?
1.
And how many boxes are there on the bottom of A?
3.
Won't that give me the same thing?
Can I just like reduce 2/6 of them?
Yeah, you can.
Oh, they got the eyebrows.
Okay, I am going to release you to finish the rest of this packet. There, some 1, 2, and 3. If you look closely on number 1, I would count across. So right here and right here. Look right here, because y'all are going to ask me this. You're going to ask me this, and I'm going to say, I told you to count across. Count across and across.
What is A? What?
A is right here. A is the small one. This is A. Okay? And then on this one, I know it's hard to see, so that's why I'm drawing it with you. This triangle right here, this is A, and then B is a part of the same triangle, so this is B. You see it? And then on number 3, they are parallelograms.
You can't even see them.
That's why I'm helping you out. That's A,
Oh, that's how it is.
and then B is inside of it.
I got wrong with it. Oh, they are.
Okay, the ones on the back you can see better. Those just those 3.
Oh.
Okay, so you need to finish 1, 2, 3, 4, 5, and then on the back 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, there's 2 parts to every question. Is it an enlargement or a reduction? Then find the scale factor. 2 parts to every question.
I feel like this is more than one of those.
Absolutely.